So a couple of you said, oh come on, you can't give up that easily. What are you? 1.5 pi agree. So let's peel this back a bit and see how deep the damage goes. These windings are quite small, like the gauge of the wire is quite thin, so I'm not too sure. If it's punctured one, that's fine. If it's punctured a couple, well, how do you know which one to hook it up to? So let's peel this back a bit. There it goes. But thought it was stuck to it for a bit. We got a bit hot in there. Of course, you don't want to scrape off the enamel on the windings so that it doesn't end up touching the one next to it and shorting out a turn. Okay, so what have we got? Is that winding? That winding? That one there. The other half of that first one. That one there would be the other half of the second one, just being side by side. And then further in we have another winding. There and there. And then we have so the third one, that one and that one. And then we feels like we have the core, or maybe an insulation layer between the next ones. We've got that one there which is not broken, and one underneath which is not broken but it is charred, so it may have burnt the insulation, so we may have to try and insulate that one and that one. But it looks like 3 turns have been melted. I guess we could have a crack at maybe rejoining them. I've got some nice thick copper enamel wire on an old inductor. I believe that came out of a power supply. Of course, you know, thinking about insulation resistance and all that sort of thing, I don't know what sort of voltage that enameling there would be rated to, if that would be of great significance. This is quite a darker enameling, so it must be heavily coated. But I guess we could join, insulate with some tape, then join the next one, insulate with some tape, and so forth. It may not be so big a deal. I wish I had a variac, because you could easily safely bring it up on a variac to check the outputs within spec then. Well, there's a bit of a close-up, and you can see we've got there's your two windings there, these two down here, and the one in the middle there which hooks up to this one, and whatever this is here, whether it's foil, plastic covered foil of some sort, I'm not entirely sure. And then this has been affected but not broken, and the one underneath it there, and actually the one underneath that's got a burn through the enamel as well, so that'll need to be addressed. I wonder if it would be, do I deal with that, or do I cut the top one and move it out the way and then rejoin it? How about a little bit of a clean with some alcohol, see what happens, see how shiny it is under there. So how bad is that one? Let's see if we can test for a resistance breakdown on that coating. That still feels fairly well coated. Okay, I'm getting a measurement there, so it is broken just here. So we will just need to insulate that. It's just hard to know if it's damaged on the underside and might connect through to here, but that's alright. I'm pretty sure that's just plastic. It's just a lump of plastic, melted plastic. Okay, well this looks shiny, but it's not conductive. Maybe I try and wrap some Kapton tape around this one. Do I even need to go around it? Yeah, I need to separate it from the one beside it that is under that one, so that one down under there, because that's got a scar as well that'll be exposed. I mean, these things, they don't have to sit in a certain position as far as I know. They'll still work as a transformer. It's just the number of turns ratio that matters, but maybe not how pretty it looks. So even if a couple were out where it were sort of pushed over one way, it probably wouldn't affect anything. Do we even need to go under? We know that the piece underneath is not conductive. We only need to keep that separate from the other ones. So maybe I save myself a whole lot of trouble and just go over the top of it. Kinda does it. See if we can tin the ends of this first. I'll put a bit of flux on there. Seems to be taking all right. We'll put a few layers of tape, maybe 2 or 3 layers of tape there where it's super exposed. That's not looking too bad. We can rejoin the last 2 and hope that everything else is fine and there's not a thermal fuse buried in the middle that's pooched. Get that little copper bubble off. It's a bit mutilated, maybe just cut off. We'll cover that one as well. But the question everyone is wondering is, do we have continuity across the winding? Let's find out. Now, I'm assuming it is the primary winding. Where's the secondary winding tap off? I'll have to check them, I guess, too. Okay, primary winding, we have 1.5 ohms, but we already know that it's the number of turns that matter, not the number of ohms. So it's either completely stuffed or completely fine. Our secondary windings, now I'm not too sure which one's which, but I'll just probe them anyway. Fairly next to nothing resistance. Those ones there, which I think are the other one, are fairly next to nothing, and then that's possibly a center tap. So they all seem to be joined in some way or another. Let's just roll with it. There's an overall view of it. Perhaps instead of running it on the amp, we'll just leave the secondary unplugged, and we'll just make sure the primary is okay. So let me find a power cord. Now I've got one with a decent length on it, so I can put some distance between me and it. And it's not going to, there's a circuit breaker here, so if there's a short, it's either going to blow the house fuse or this is going to pop. Hopefully this first. I don't really want to blow the wall fuse, but I'm sure it's rated at a bit higher than that. This is all we can do. This is what you guys wanted. In 3, 2, 1. Well, there's no smoke. I guess we need to see if we have a secondary voltage. We're on volts AC. Now I think this is one of the windings. I'll try not to touch the probes with my fingers in case we got quite a high voltage coming off there. Look at that, 139 volts. So see, don't touch your meter probes. That would hurt. Let's go to that one there. Oh, that's better, 70 volts, because we are expecting that. So maybe, you know, across the wrong set of windings, it is going to be a higher voltage. 18, two end ones there are 37, and the two bottom ones are 50. What about the center to bottom one? Ah, yep, so there's 69, so we've got 3 across the top. The center one to the 2 side ones look like our 265 volt according to the schematic rails. And then the end 2, 37, not too sure. I think it was 2 lots of 18, so this is our common in the middle. So that looks like it might actually be doing the business. Let's get it back into the chassis and plug it in. And hopefully get our secondary plugged in. Be careful with this board, it's not very well supported. I did pop that fan blade back in and it does spin, although it's not captive, it would fall out again. So I'm turning it on. Alright, we have fans blowing. We heard relays clicking. And we have power light. No fault light. So checking our HT rail there, and we've got plus 93 and minus 93, so that's good. Then somewhere around here we're supposed to have plus or minus 18, so I think it's something like here's minus 22, have I got the right point? Oh, 24 and minus 24, that's what we need. Yeah, so it's like plus or minus 24 there, so that's close enough. Let's check the speaker output for DC. There wouldn't be, the relay wouldn't have clicked on if there was, so I guess that's fine as well. I guess we should tend to this. Now, having played with them before, I'm pretty sure that if the pot itself was salvageable, trying to bend the shaft straight is just going to snap it off. You only get to bend them one way. So that nut's not going to come off given how crooked the shaft is. I'll just nip that back up, and give it a pull, and I don't think this is going to go well at all, but it has to come out either way. Nope. What I tell you, you only get to bend them one way and then they snap off. It's just yeah, one of those. pretty straightforward. How many ohms? What do we got there? I think it's 60k. No, 50k. I'm going to go with 50k. If I probe across the two outside pins, which is our full sweep, it is in circuit a total of any minute now. I'm going to go with 50k. Got our new 50k pot. So it's got some horrible white stuff on it. Let's see if we can cut through that. I don't know if it's glue or silicone or what it is. I want to try and keep as much of the length as we can. There's a little bit spare, but it'd be nice not to shorten it too much. And we can see they've heat shrunk the center lead as well. Interesting, good attention to detail, I suppose. So if there's I don't know how you'd ever accidentally knock it to join the two together, but there you go. Mount that in a vise to make it easier to undo the, pull the wires off it, because they are looped over. Now, of course, making sure to keep this order, otherwise up would be down and down would be up. These are designed to be PCB mounted. By the look of it, they've a lot finer pins coming out the end there, so you want to be careful with those. It's just, it does say 50k on them, but just on the off chance, I'll just double check, make sure that's 50. And our second one there, I might just pop a little bit of heat shrink over, because they are flexible, they could actually push into each other, so we'll put a little bit of heat shrink on the ends too. They don't have a hole in the terminal for you to loop the wire through like the original. You could purchase the original ones, I'm sure, but as always, everyone's on a time budget and everything always breaks at an inconvenient time. I think this heat shrink might be a little big, but it's all I've got. Tin the pot. And of course put your heat shrink on before you solder them, and I'll put some hot glue around that to strengthen up the whole thing. There's my tweezers. Just hold it in place so the air doesn't blow it back down the wire. Pop it back through the front. Oh, actually, I just noticed there is actually a small hole in the case for the locating tab on the pot, which does happen to be up the right way, or the same way on the new one. Oh, it's got a different locking tab. Let's see how far out it is. I'll just grab the other one and poke it through the front ways. It's quite a way off. I need to either make that hole much bigger, in which case it won't do its job, or I wonder if I can elongate it. I really need to drill another one a bit further down there. Well, looking at that, we need to go roughly there. So let's go roughly there. We need to go there. Let's see if I can center punch that. That still made a dent. That works. Barely. That's as good as we're going to get. Hopefully this 300-degree range of motion is a standard on these things. That should be half. It's close enough to the other side. A big old blob across there. Just going to pop some more tape over our repair there, just some bigger, thicker insulation tape, just to help prolong that. If we left it as is and the Kapton started to let go and fall off over time, it would have exposed wires there that we do not want, so we may as well just go over top with it. That should do it. So according to the interwebs, I don't have an XLR lead, but you just need to bridge pins 1 and 3 for negative from an RCA lead, and pin 2 is your positive or center pin of your standard 2-wire audio signal. And then we can turn this thing on and feed a signal in and hopefully get an output on the scope. So I'm going to start with 100 millivolts signal, because I don't know how much XLR is allowed, and point you at the scope. Right when my battery's about to die. I swear this new battery has not lasted long at all. Turning on, and turning on signal. And look, we get a little bit when I turn the volume right up, which means we can go higher on the input. How about 500 millivolts? Here we go. Maybe we can go higher than that. So if here's a 1 volt input. Well, the interweb says 1.7 volts peak to peak, but at that rate we're getting an output of about, what do we got there, 60 odd volts peak to peak. So yeah, sure, okay, whatever. And we'll look at the other channel. Looks good to me. And the other channel, just the same. So thanks guys for giving me a push to actually try and fix it instead of just brush it off. I thought there was more damage to the transformer than that, but yeah, it's always worth a second look, right? That fan's hanging in there. If he wants to, he can pay for a couple new fans. I'm just going to leave it at this point, leave it up to him. He's got new controls on the front, so the whole thing's going to function as it should. So I guess if you like that follow-up, give it a thumbs up, and we'll see you all in the next one.